Today what we're going to do is we're going to look at, we looked at rational and irrational numbers last class. And today what we're going to do is skill 2, which is our operations with those. So adding, subtracting, multiplying, and dividing. Now, the nice thing about this is that they come in pairs. And then the next thing to say is there's also these nice things with our calculators that we can do to make our lives easier. All right, so some vocabulary, and honestly, the last one is not on the exam very often whatsoever, but let's just review. What does it mean to find the sum? What are we going to do with our two numbers? Add them, yep. We're going to add them. Only the word difference comes up, and that's subtraction. Not necessarily in these questions, but it's definitely one that's on there. Product is the other good one. When we're finding a product, what are we doing with our two values? Multiply, right? The one that you don't see is quotient very often, and that's division, or to divide. Okay, so sum, and you guys are good with these. I mean, product, I think, is sometimes the one that we forget, but hopefully we can remember. Sum is to add, and difference. Multiply is good. They come in, when we're working on today's lesson, if we talk about addition, then subtraction follows the same rules. If we talk about multiplication, division follows the same rules because of like the idea of them being inverse operations, okay? So they undo each other. All right, so now let's just, last class we talked about rational numbers and irrational numbers. And so we're just coming up with a couple of each to play with. So a rational number is a really easy number to go with. What about the number 3? Is that a rational number? Oh, yes, it is. So 3 is rational. Let's also say the number 0 because that's kind of an interesting rational one. And let's do the fraction. Good morning. 1/3. I like 1/3 because 1/3 is going to be a decimal that does what? Try it at your calculator. Do 1 divided by 3 in your Chromebook. If you don't know, now you need to know. What does that decimal do? It repeats. Thank you very much. Just updating my attendance. Morning, Jocelyn. How are you? Good. We just got started. This piece of paper's on the desk. And then you'll want your Chromebook with the decimals calculator. Okay? Thank you, dear. So the reason why I like this one is because it is 0.3 repeating, right? That's a repeating bar. It's a really ugly repeating bar. I can fix that. There we go. So our repeating decimals are rational, so are our decimals that terminate or end. Those are rational. All right, so irrational numbers that are good to play with. It's good to play with, you can always use the symbol pi if you want to, but maybe some easier ones are going to be things like radicals, okay? So remember, a radical is that we sometimes just say square root. Okay, there are other types of roots, but if we look at like the square root of 2, we know that's going to be irrational. It's going to never repeat, and this is so important because you have to say and never end as a decimal. All right, and we'll just put down one more of those just in case we need a second one. Now, square root of 4 would be bad because radical 4, square root of 4 is equal to 2, right? That's what's called a perfect square. So we're going to go ahead and do square root of 5. And now we're just going to play with some examples to figure out what patterns exist when we do operations, add and multiply with rational and irrational. If I have 2 rational, what happens? If I have 2 irrational, what happens? If I have 1 of each, what happens? Okay, ready? All right, so let's go ahead and do an example of a rational plus irrational. All right, let's do 3 plus 0. Well, that one we can do in our head, can't we? What's 3 plus 0? 3. And so we just did a rational plus a rational, and what did we get as our result? I'm using R for rational. Does that make sense to everybody? get another rational number. Now, will that work if I do 3 plus 1/3? Will that still be rational? Let's try it out. So, yeah, so this is where we have to convince the easiest thing to do when you're jammed up is try to use an easy example. So if I go 3 plus, and now I'm going to put that division bar in, and I love this that it automatically makes a fraction, right? 1/3. There it is, 3.3 repeating. So that's rational, right? Because it repeats. I can put a repeating bar on it. So we have proven, using just 2 examples, that a rational plus an irrational is rational. Okay, so now we're going to try our next one. We have to do a rational plus an irrational. All right, let's do 3 plus the square root of 2. All right, so you're going to write that down, and then I want you to type it in your Desmos calculator and see what you get. If you want to do some different work. Okay? All right, so when you guys put that one in, I'm just going to clear this one out. I could have just edited that, couldn't I? 3 plus, okay, so the nice thing is this is forward function 2, and we hit enter. Oh my gosh! What's good about that decimal? Anything, or is it ugly? Ugly, ugly. So if we do, so I'm just going to write down 4.14. Oh, I put 4.1, sorry. 4.1. 4.1. Blah, blah, blah. That's so when things are blah, 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 afterwards, I usually just do that. Like it's yuck, right? There's no pattern. I can't put a repeating bar on it. So when I did a rational plus an irrational, what did I get? Did I get a rational number or an irrational number? Irrational number. Very good. And that's always going to be true. So these are some patterns that they're going to ask you about. Which thing turns out to be rational? Which one turns out to be irrational? So now we have an irrational plus an irrational. So we want to try 2 different things. We want to do radical 2 plus radical 5. But you also want to try just doing radical 2 plus radical 2. Does that make sense that we would want to repeat the same number to see if there's anything weird that occurs? Okay, so try both of those in your calculator and see if you get garbage or if you get something nice and pretty. Okay? You're signing in. So you just want to find an empty desk with a folder. Yeah, folder and paper. Do you want to sit next to Chris, please? Not today. How about tomorrow? You might be able to earn that. So there's an empty desk next to Chris with a folder of papers. All right. So I want to say, and I'm just going to hopefully go up here and edit this one to make my life easier. Both of these turned out to be garbage. Am I right? So if we do the radical 5 here, yuck, that turns out bad. Radical 2, we got to make sure we get out of that radical symbol. Plus radical 2. Did anybody have trouble with that? Right? They both turn out to be ugly, ugly. Right? So it doesn't matter. And I'm not going to take the time to write them down. I'm just going to put this yucky here. If you want to, you can be like, it's really yucky. So an irrational plus an irrational is always irrational. So something that's nice about adding, and it's true for subtracting as well, is these rules are solid. There's no weird things that can occur. It's always going to be this way. Okay? All right. So now multiplication is where things can get a little wonky, but not that bad. All right. So we're going to do rational times rational. So let's go ahead and do the same things we did before. We can do 3 times 0, and we can do 3 times 1/3. And let's see what kind of answers we get. And some of you might know those already in your head. Okay? I can charge it. I'm happy to charge it for you. So get it out. Don't forget it. Okay? And that way you'll have it for the rest of your day. Can you check your butt bag for me? It's tough having somebody that cares about you. Okay. anything times 0 is going to be what, guys? Yeah, that's right. So that's rational. It's a whole number, but it's rational. Ooh, I like you. There we go. Is there one on this side that works? Yep, okay. So open it up when you have a chance and go to the Google. So this one turned out to be 0. What was the answer to the other one? 1. Oh my gosh. So a rational times, I'm going to use a multiplication dot, times a rational is always going to be a rational. All right. So now let's play around with this stuff. Bless you. All right. So if we do a rational times an irrational. So let's try doing 3 times radical 2. But I also want to do 0 times radical 2. And let's see what we get. Oops, let me X this out and X that out. All right, so 3 times radical 2. Ooh, that one's ugly. Okay. So this first one turns out to be irrational. I'm just going to put the I in here just to make it a little bit easier. But 0 times radical 2 is going to have to be 0. So this is where the rule falls apart. Okay? The rule falls apart because sometimes when you do rational times irrational, and really it's all the time you get irrational, except when you do 0 times irrational, right? So the only time it's going to fall apart is, and that's a rational, is if R equals 0. So this is 99.9% of the time true. So we can't say always. We can say sometimes or almost always, but we can't use that always true idea. All right, so that's something different. All right, so then our next one is an irrational times an irrational. And this is also the one that can get a little bit wonky. So we're going to try, like we did up here, radical 2 times radical 5. But I also want you to do radical 2 times radical 2. Excuse me. Awesome sauce. I'm just going to take you. Yep. So if you use the calculator with the green bar, that's going to be the one that's going to help you out. Okay. Am I going too fast for anybody? Is this making sense? Okay, jump. Of course. What'd you get for those two? Okay, try these. This is the one that's interesting. Like some of these are kind of like, duh, of course root plus 0 is going to be 30. Like that's kind of, you know what I mean? Like that doesn't fool with us. All right, stay with us on this one first. So I want to know, really quick, back here. So this times this is 4, you're right. But if this had been a 0, right, you would have gotten a 0, which would have been a rational answer. So it doesn't always turn out to be irrational. Same thing down here. This one turns out to be irrational, but if this had been radical 2 times radical 5. Okay? All right. So let's see. So an irrational times irrational can be irrational, so this would be an I, but this one turns out to be rational, right? This turned out to be messy. Okay? So don't get too far ahead of me. I put that up because I wanted to talk to you about it. I necessarily want you to go jump in it. But no, I just put it out so we could talk because I don't know how much. Obviously, you're coming with knowledge, right? And I don't want to waste your time, but I also want to make sure you aren't carrying big mistakes. Does that make sense? So, or small mistakes. Okay. Did you do the questions already on the back? Okay, here, go ahead and play with it. Forget it. I love it. Go ahead and play with it. We'll talk later. Okay, what was radical 2 times radical 5? Was it nice or was it ugly? Ugly. Ugly. But, friends, what happened here? It turned out to be 2. So this is the other one that can be yucky. And it doesn't have to even be, so an irrational times an irrational often is irrational, but I can have also an irrational times another irrational that turns out to be this. And it doesn't have to be a duplicate. So the thing we want to do, and it's hard because you guys are maybe not like, I don't like these numbers, but you have your calculator to always guide you, right? And you know the difference between a yucky number that never ends and never repeats, and then you have the other number. So if you flip your paper, we're going to do like 4 questions that are Regents questions together to get the idea of how easy this type of question is. It's guaranteed 2 points, right, people? Did you put it in? Thank you. Sorry. Okay. Let's see how we do. So we're going to do these together. Up here. All right. So first one. So it says, which expression results in a rational number? Say you don't even remember what that means. You would put all 4 choices in your calculator, right? And do one of those things that we all saw on Sesame Street maybe when we were kids. Which one of these is not like the other, right? It's kind of like you look at the 4 answers and see which one's different. Okay? All right, so let's go ahead and start there. Go ahead and by putting the 4 choices in your calculator and see what you get. Give it a whirl, you can do it. Show me what you can do. Thank you. Thank you. I don't know. Did you put all of them in? Okay, so first of all, get to our Google Classroom. And then you always want to use, once you get there, the link to the proper decimals calculator. Okay? You want to do all 4 of them and then try it out. So we're on this one right here. I know there's another paper that looks a lot like it. Okay. So this actually is a good example of, even though the radicals are different, and then make sure you get out of that radical. Whoops. Mm-hmm. Do I have an onion ring? Oops. I always do this. There we go. I think we did this one on our thing, right? We already know what this one is. Yuck. I'm like, so I keep on forgetting to hit enter. I do have no music though, okay? Everybody can hear it, and it's not allowed, unless I say it's allowed. There will be time that you can listen to music, but now is not the time. So I don't want to have to talk about it again. Please and thank you. Okay, so if you put all 4 of them in, what's the only one that's in by itself? Number 1. Yeah, number 1. Life is good. So even if you didn't remember that rational means that it's a fraction, n over m, these are integers, you can write 6 over 1. This is the only one that's different. So why don't you try the next one? Go. Of course. So the next one is, which one is going to be irrational? And there's all our crazy stuff going on here. No. Because
I see it.
You see it now? Cool. This is a good time you can use your settings wheel and do a delete all if that helps to clear your calculator. Okay. Okay, what'd you get?
3.
Yeah, okay. So so this is a reason why it's so important for you guys to do stuff in class, because then I can see
I had a bunch of people do this, and it totally makes sense. Square root of 16, and you hit the plus sign, and you're still stuck underneath, aren't you? So you got to make sure you get out of that square root by just cursoring over, or you guys have, except for one of us, we need to get you a touch screen, my friend. All right, you got to get out of there by using your cursor or by tapping over. Then you can add. So the correct answer is choice 3. But Gabby, I love that you said they're all irrational in the beginning, because they all have radicals, but the square root of 16 is equal to, do you guys know? So when we first look at this, I see all those radical symbols, right? We're like, irrational, everything's irrational. But that's not true, because what's the square root of 16? 4. Because 16 is a perfect square. That's why it's called a perfect square, right? Squares have equal sides, right? We learned that back in elementary school. So the fact that we have the square root of 1, that's equal to 1. So really, this answer was 5. 4 plus 1 is 5. And we get to, my son has trouble with this math fact. What times what makes 49? It has to be the same number squared. It's going to be our 7s. 7 times 7 is 49. But when you put the square root in, this becomes 7 plus 3. And we don't have to remember these, but if we type them correctly in our calculator, we can get the answer right. Okay, cool. So now this one is a little bit harder to type in, and this is, remember friends, those 2-point problems, 4-point problems, and 6-point problems in the end, you've got to try some of them, because if you leave it all blank, you're not going to make it. I know there's 24 multiple choice, and we think we're going to make it, but we can't. We got to get some points in the back. So it says Jacob is working on his math homework. He decides that the sum of the expressions, and isn't it nice, they already put the plus sign there, must be rational because it's a fraction. Okay, whatever, Jacob. Is Jacob correct? All right. Well, at least the first thing we're going to do to see if we can squeeze a point is we're going to see if we can type this in Desmos and write down an answer. Okay? That's step 1. That might get you 1 point out of 2. Okay? So try typing that one in Desmos. Can you give that a try, please? Right here. Okay, so we're on question 3. And it's got that crazy looking stuff. Do you know how to make fractions? Okay, so a fraction can be made by doing the division sign. So if you pull up this little keyboard, that's going to help you. There you go. So find your divide. And then. So this is a kind of a really ugly fraction on the other side. Remember, if you hit your fraction bar, the fraction opens up right away. And then underneath, we're going to put a 7. So in the empty space on your paper, you would have to write down that you're doing the addition problem. Okay? Does that make sense how I got that answer? Or typed it in? Yep. Okay, you're getting close though, so go. Yep, you got it. Okay. Do you have your Desmos calculator up yet? Okay. Okay, so what I want you to do is always go to, see how you go black bar here? So if you go to your Google Classroom, this area is this one. Can you go to your Google Classroom? I don't want to be your boss. Here we go. So right there, use this one. Okay? That's the one that's going to match what you're doing. Okay? All right, so now go ahead and see if you can type that in. What did you get when you typed it in, buddy? Oh, so you can X this out if you want, or you can just open up a new line, whichever makes you happy. All right, so can you type that in? Okay, so on your paper, you have to write down that you're going to do this math problem. So there is a little bit of work to show. Or you could probably do depending where it is, you could circle it and then say equals, and you're going to write down 2.24996 ... There's no pattern, there's no repeating bar. All right, so you write that stuff down. Okay, and then that should get you 1 point. But let's see what we should do. It says, is Jacob correct? Is this, actually, here we go. I wonder what Do you guys see how there's no fraction thing here? Remember how, like, if you put in, I'm going to show you down here. If I put 1 divided by 3, do you see how right here there's a fraction circle because it converted back to a fraction? It can't convert. When I'm up here in this one, it can't convert it back to a fraction. There's no way that this is rational. So, is Jacob correct? Jacob says it's rational. So you have to say that Jacob is wrong. And then just for the sake of you having practice writing this reason, if you could write it down with me, that'd be great. And then you guys are going to have a closing activity, and then that's today's lesson for today. We're almost done. So Jacob is wrong because, and I would say the number or the answer is irrational. And then in parentheses, I'd put that reason why it's irrational. How do you know? It is a decimal, or it has a decimal that never repeats and never ends. So the key to getting that reason correct is remembering both things. It never repeats and it never ends.